So let's finish, let's wrap up this day with a super fascinating topic. I think what is really important here, I thought I would see the slides here, but I will need to turn, so maybe I will take the mic. So what we are going to see together is what Mustafa announced at the beginning of the day. The key is the intelligence. The key of everything we are doing, it's so complex what we are doing that we will need some intelligence to solve it all. And let me bring you to a small journey with the concrete examples along the way of what we are doing today, what we are going to do with 5G Advanced, and have a glimpse into 6G. So what's fascinating about this topic is really about the correlation, the fact that there are synergies between 5G and artificial intelligence. As an example, you know, the 4 categories that are spread here are all mutually benefiting from AI and from 5G. The baseband, we have talked about it a lot, whether it is based on GPU or CPU, and Mr. Yu talked about it. The baseband, intelligence, and the medium access will benefit from AI. Second topic, the network side. We will enhance the capacity of the network. We will enhance the mobility capabilities very quickly because of the fast resource allocation. And we will, above all, very important for the operators, we will have power savings at the network level. Third category, at the device level, also we will have energy savings. We will have also antenna design and RF performance that will be improved by artificial intelligence. And last, when we have done all that we know for the 5G communication side, then we have also vertical applications, meaning we can apply all this artificial intelligence to do environmental sensing, to do other application of AI to correlated topics. So this one is the most important slide. We are all at the end of the day, so this is the most important slide of the presentation. Why? It's because until now, what we have discussed was the cloud and the edge cloud. What about if we continue the journey and we put the artificial intelligence into the device to continue to spread the computing power up to the device? And this is the vision of Qualcomm of having to lead the connected intelligent edge. What is the connected intelligent edge? This is this reunion of edge cloud and the device. And what is in the middle? This is key for GTI. What is key in the middle is the network. So the optimized network, it goes hand in glove between the improvements on the device thanks to artificial intelligence and the improvement at the edge, as we have discussed with Mr. Yu. So this, if you have only one thing to remember, what we can call hybrid AI, which is really the distribution of the computing power across the network up to the device, is really a game changer, where we can really, I would recommend, as Mustafa said, intelligence, the key is intelligence. So it would be probably a very good new topic for GTI, and we would be very happy to collaborate to it. So it's starting already today. Already today, we have a few examples that we have demonstrated at Mobile World Congress Barcelona as an example. So we have our latest chipset, Snapdragon X75, that was announced, by the way, at the same time as the red cap that Shirley talked about, X35 red cap. So the X75 is 2.5 times more AI performance. As an example, when we apply this chipset to millimeter wave beam management, which is extremely important in all the 30 countries where millimeter wave has been deployed, then you see a 25% higher receive power. And another example is GNSS, where you're improving by 50% the location tracking accuracy. So this is already happening today, those improvements generation after generation in the chipset. Equally important, of course, is the generative AI. So when I'm talking about computing distribution, it's good for the communication to improve the system. It's also good for the consumer because they can use the computing power in the device, and also it will be much better from a privacy perspective and from a latency perspective if part of the inference or all of the inference is done in the device when they are doing some generative AI. I say part because, of course, they can be the dialogue, or it can be all because everything can be done on the device when we improve the capabilities. At Mobile World Congress Barcelona, we have demonstrated 1 billion parameter model running on the device. Before the end of the year, we hope to show 10 billion parameter model running exclusively on the device. For the sake of the demo, we put the flight mode. But of course, it is even better reinforced when there is a dialogue between the device and the cloud. So of course, it will enhance the privacy, the security, and the cost, of course. Even I would go one step further. There is a business model for the network operators to be able to probably to monetize the fact that they are distributing. Because what do you do as a network operator? Very often, in one form or another, you are subsidizing a part of the device costs that your consumer are having. You are giving some discount on the plans, on the tariff plan, etc. So by having these over-the-top players that are the cloud people that are really in need of this computing power for inference of large language model or large video models, then it will be a possibility to monetize for the operators. So let's explore together also business models that can derive from it. But if we come back to everyday system, I will give some concrete examples of what's happening, where it's happening. So Mr. Year already discussed about this intelligent disaggregated network and the optimized distributed cloud. So this is, we are contributing a lot on this aspect. The future is the data-driven. In the second half of the slide, the data-driven channel model will go further into having really a dynamic air interface. So this will be more for 6G timing, but we are already studying it from a fundamental research perspective. And on the smart edge devices, the last part, this is where we can already apply some of the examples I will give in a minute. So what we do, for example, we apply AI for network planning. We talked a lot about 5G private networks, we talked a lot about digital twin today. But imagine that, when you are doing your network planning, you are creating automatically the digital twin with the resources that are on the web. We took all the buildings of Manchester, England, we recreated the digital twin of the city, of part of the city, just by collecting information from the web and by running artificial intelligence model for it. Equally, we after did the ray tracing. Instead of sending people, to do RF measurements, ray tracing is quite complex, nonlinear, etc. We are better off to do it with AI models that are doing it. And finally, we can also simulate the user experience by applying those AI models. Another example is in private networks. You know how important in this case is the service management and orchestration, to have flexibility on the resource allocation and to be able to scale the resources, or also to have a precise positioning of the objects, of the assets that are in the factories. We have proved that with AI you can have a much better positioning capabilities, and these are, I would say, well, you see the little triangle, these are YouTube videos that you can look when the slides are distributed on the GTI platform. So the journey has already started. What's next? What can we do with 5G Advanced when we really start the clear era of wireless AI? So of course you know that we don't need to spend time on the timeline. So on the examples that I wanted to give you, so this is really the dual node, the cross node type of AI between the network, the base station, and the device. Channel state information, as an example, can be predicted much better if it is not just predicted at the base station level, but if it is also done at the device level, and it gives the feedback loop to the base station. So AI inference at the base station, plus AI inference at the device. At the moment, we don't have yet, in 5G, we don't have yet AI native encompassing all the system, but we have at least the possibility to run two inferences and to reinforce each other and to improve as an example, the CSI. I gave the example of beam management for millimeter wave. Extremely complex to measure. We never know which beam will be, There is contextual information coming from the device that can sense the environment, and the AI can very quickly close the loop and zoom on the right beams that will be best to do the real measurements. And as another example, precise positioning will be another example where instead of doing downlink TDOA, you can use several base stations, locations, positioning to improve the calculation. So in summary, for 5G Advanced, a lot of things are already in the release 18 scope. So I gave you a few use cases, but of course you have models, you have network optimization, and you have future studies. Beyond release 18, not yet fully defined, of course, by 3GPP, release 19, release 20, but again, you have new and expanded use cases at the bottom, plus of course network architecture enhancements. I leave it to you for your reference in the slides that will be distributed. So we are already working on those study items. But it would be very, I would say, a mistake to wait until release 18, release 19, release 20 to benefit from those. So let's not forget everything that we have listened, everything that we have learned together in the course of today. That was basically, we talked a lot about 5G standalone. I'm very happy that we have talked so much about it in all these examples that many of us have given, because this is the way to unleash the full power of 5G as we know it. We are already midpoint. We are only midpoint into the lifetime of 5G. With 5G Advanced, we can really go into the second half of the lifetime. So by having AI ML for the networks, and I will not repeat everything that has been said by many of my colleagues of today, we can really make AI benefit almost all the chapters of 5G standalone going forward. So the call for action, I know for Chinese operators it's already done, but for all the operators that are listening to us today, I hope that we have convinced you during the course of today that 5G standalone is the right way to go and to implement it in a fashion where you can really benefit from those advancements. Finally, of course, we are driving at Qualcomm foundational wireless AI innovations that are leading towards 6G. So people are thinking about, we have a dedicated research institute dedicated to AI at Qualcomm. And people are very often thinking about, fundamental research. These guys are, doing equation and AI research into deep generative model, into self-supervised learning, etc. But we are also very, very much interested in how does it apply to the reality. So platform research is equally important because this is when we test, for example, that all the techniques we are inventing in the fundamental research are also power efficient, are also going to work on a platform, on the real platform of the chipset for devices, for the cars, for the PCs, for the smartphones. So we test the computing memory, we test, and we have given a toolkit, AI model efficiency toolkit, IMET, to developers so that they can test. It is available on GitHub. And finally, we do applied research. Applied research, as I said, is applying not only for communication systems, but for RF fingerprinting, for deep learning, for graphics, for voice, user interface, etc. So the applicability of our fundamental research spans across different verticals and different applications. So in summary, I hope that was a short journey between now and 6G. We have so much to do with 5G standalone, with 5G advanced before we move to 6G. So the rise of AI is bringing a unique opportunity for the operators to improve their network efficiency. The key is the intelligence. The key is the intelligence to deploy in your network and to offer to your consumers when you distribute the computing of generative AI on the device. AI is playing an essential part of in every part of the cellular system. And of course, 5G Advanced is starting this era with 5G standalone today and moving into 6G. So we are very happy at Qualcomm to drive some of those research, and we have heavily contributed to some of the papers that were presented. We would be super happy and super humble to contribute also to some new papers from GTI that are related to 5G and AI. Thank you very much.
Thank you so much. Thank you. Thank Qualcomm support for GTI, as always.
You're welcome.
Questions? Comments? Okay. Thank you.
Thank you.